Hello guys and welcome to our next video. This is going to be another UCAT video and we're going to do this on the decision making section. Now if you're like-minded like us, so you're mainly scientific, then this section shouldn't be too bad, although there are some things to be aware of and we'll highlight them as we go along. So it will be the same style as our verbal reasoning question. Make sure to check that out if you haven't already. And we want you to do the questions alongside us and then we'll explain how we work the questions out. So this will be live.
Yes.
The first type of question we'll go through are the yes-no syllogism questions. So these are when you get several statements on the relationships between different things. So maybe like all A belongs to B, some B belongs to C, things like that. So you have to decide whether each conclusion follows from what you're given. So, as always, have a go at this question. So we're told that all people who live in the house except for Jim like tea. So only Jim does not like tea in the house. More than one person in the house likes coffee. In this situation, because it concerns an individual, it might be a bit difficult to use Venn diagrams to represent the information. Only when they talk about groups of objects are Venn diagrams more useful. Jim likes coffee. Not necessarily. If a person in the house does not like coffee, they must like tea. That is not necessarily true, because Jim might not like coffee and he might not like tea either. If a person in the house does not like tea, it must be a Jim. Yes, that's rephrasing the first sentence. If only two people in the house like coffee, one must be Jim. No, someone in the house likes coffee and tea.
Yes.
So let's say there was a situation where there were only two people in the house. One of them was not Jim and the other one was Jim. More than one person in the house liked coffee. So yeah, even if there were only two people, that still holds. So can you see I'm going through the most extreme scenarios and making sure that it still holds. So, no, no, yes, no, yes. So that's a straightforward one. You do get some of these straightforward ones, but it doesn't necessarily follow that just because they're short is that they're straightforward. So you still have to think very carefully about all of them. So you can see that one I didn't have to use a Venn diagram, kind of thinking through the different scenarios in my head would have solved the problem. Now we move on to the next type of question, which is the logic games. Definitely use diagrams for these questions, so I'll let Kusha take over this question.
Alright, so 5 tourists from different countries wore shirts of different colours. Okay. For these sort of questions, I just, instead of doing like a Venn diagram, I just write C. Oops. What? C.
Essentially, you draw a table.
Yes. And then A. Or to save time, you don't actually need to write these, because you know the order from the question. No two tourists. Okay, and then there are different colours there. No two tourists wore hats and shirts of the same colour. Okay, so that's fine. French tourist wore a green shirt. Her hat was neither red or blue. So, you know that shirts. This is hats. So the French tourist wore a green shirt. Hat was neither red or blue or green. So it's either brown or yellow. American tourist wore a red shirt. Okay. Italian tourist wore a brown hat. Okay, so you know that the French tourist wore a yellow hat. The colour of her shirt was the same as the girl, so you know this is yellow, which is true. Italian tourist wore a red shirt. That's not true. American tourist wore a red hat. That's not true. American tourist wore a yellow hat. That might be true. Chinese tourist wore a blue or brown shirt. That's definitely true. If it's green, red, yellow, so it's going to be blue or brown. So it's probably D.
Yes, and you can see they've done pretty much the same table, just in a more elaborate way. So to save time, obviously make your tables as simplistic as possible whilst making sure you still understand what you write. So these recognizing assumption questions, they give you a question, and the question consists of two parts. One part is a proposal. So in this case, it's should the legal voting age be reduced to 16? And then the second part is the goal. The goal is to overcome the issue of poor voter turnout. And then you have to select the strongest argument from the following arguments. The strongest argument usually doesn't make any opinionated sort of claims. So people should is an example of an opinionated claim, but something like it's been shown or studies back up, that's backed up by evidence, so that's more likely to be true. Also, it has to be relevant to the goal. So if it doesn't talk about a goal, in this case, the issue of poor voter turnout is unlikely to be correct. But obviously, each question is different, and you have to find the best fit. So the best fit might not always have all of those things. So in this situation, we want to see something that addresses the issue of poor voter turnout. Let's first eliminate the ones that are wrong. C is definitely wrong because that's an opinion. They are not engaged enough. Well, we don't have any evidence to back that up. Giving 16-year-olds the vote will increase the number of people eligible to vote. Yes, but that won't increase poor voter turnout. It will just increase the sort of voter population. If under 18s can vote, politicians will listen to them. Well, that's not relevant because it's talking about under 16. It's talking about 16-year-olds rather than under 18s. So that leaves the only correct answer being D.
Yeah.
The next type of question is the yes/no interpreting information question. So why don't you do this one? You need the calculator for this one, I think.
Oh, yeah.
Maybe because there's numbers. So I'll just get the calculator up. Uh-oh, this calculator is not the best. You can't change the size, so it's just this. So basically just Alt and C whenever you use a calculator.
Right. So in the actual UCAT, your keyboard will have like an attached few keys for your calculator, where you can basically a number pad, so you can type numbers really quickly, do addition, multiplication, all that really quickly, and that's really useful in the actual UCAT. So the decision making calculation questions as well as the QR questions can be a lot more quickly done with this pad. So I normally have a Mac and I do not have this number pad, but because it's so useful in the UCAT, I went out and bought a really cheap number pad, connected to my Mac, and used that for practice, and it turned out to be useful at the end. So now, see this question. A company produces two types of machines, A and B. Single unit can be produced in 100 hours, and B can be produced in 25 hours. Okay. And then there are a bunch of like combinations that a company can make of these. The only limiting factor is the labour available to the company. Okay. And it's yes or no conclusions. Okay. So an order requiring 2,500 units of machine B alone in a month cannot be achieved. I would say you're gonna have to work this out, aren't you? So 600 of making 600 machine A, and machine A costs 100 hours, so you've got 60,000 hours. And you have to do 60,000 divided by 25 to work out how many machine Bs you can make, the maximum amount you can make. So Alt C, so it's 60,000 divided by 25, 2,400. So that's obviously less than 2,500, so the answer is no. Wait, cannot be achieved. It's yes. Read the question. Yes. A target of producing 200 and 1,800 units of machine A and B respectively cannot be achieved. I'd say yes. Because if you look at the table, there's one with 150 and 1,800, and that's using all available labour. So I'm just guessing yes. A target of producing 100 and 1,200 units respectively may leave many workers sitting idle. Okay, well. I'd say yes. I'm not really doing any calculation in my head. I'm just guessing that, looking at the table, 250, 1,400, 100 extra units, and you're taking away 150 units on machine A, it'll probably be yes. In an efficiently running production system, is final machine A being produced and the machine B produced must be higher. Okay, so I know that machine A takes 100 hours, so 500 times 100 is 50,000 hours. And you've got 10,000 hours left because you only got 60,000 hours of labour. So you do 10,000 divided by 25, which is, you clear the calculator. Right, there's no shortcut for that. 10,000. Divided by 25, which is 400. So no. A target producing 200 and 1,000 machine A and B respectively. Okay, might leave. Okay, so this is another calculation question. So 200 times 10, 20,000. 1,600 times 25, 16 times 25. That's what? 40,000? I'll say no. So that's just mental maths.
Yep. Use mental maths as much as possible, but not too much that you waste more time doing mental maths than you actually would waste if you did the calculator. So, yes, 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 no, yes, no, yes, 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 no, no. Yeah, that's right. So this is an example where calculator can help you, and also mental maths. So the next type of question will be the Venn diagram question. These questions can vary from being very easy to being very difficult, and the very difficult questions will take a lot of time. So here's an example of a slightly more difficult question. In this situation, they give you the data and they expect you to form a Venn diagram from it. The best way to approach these questions is to eliminate the wrong answer options.
Mm-hmm.
So, for example, because 20 students are taking geography, 20 are taking history, and 12 are taking art, then A is wrong because one of the rings adds up to 25, the other adds up to 25, and then the third adds up to 12. B could be right because each of the rings adds up to 20. Well, the bottom two add up to 20 and the top one. Okay, so the top one adds up to 17, so that makes B wrong. C could be right because the top and the bottom right add up to 20 and the bottom left add up to 12, so you can check the other criteria. 10 are going to take geography and history, so
Can't be.
yes, that is true.
Yeah.
And obviously I want to take art as well. Yes, that also fits. So in the exam, if you found something that fits, don't bother going to check the other option. Just select it so you can save time. Yep. So if we would have checked D, then you can see that this ring adds up to 15 rather than 20, so it can't be correct. Yeah, so the yes/no questions can take up a lot of time. So if you want to save time, if you're only short on time, for example, then going to the end where easy marks can be up for grabs with easier probability and Venn diagram questions.
Yeah, like literally, the yes/no questions are they worth the same as like these probability questions, but they take so much more time than these questions. So just skip to the end if you're running out of time.
Over to you for this probability question.
Right, so Jason's dishes of ice cream. Any dish has up to 3 flavours. He chose to include an extra flavour. Is 8 the number of extra different dishes of ice cream that Jerry can sell with up to 3 flavours? What? Oh, any dish can have up to 3 flavours. Right. Right. So we're working out how many combinations there are with 3 and how many combinations there are with 4, and then just doing the difference between that. So with 3, it's just 3 factorial, I think. Hope he's not wrong, but yeah, I'm guessing it's 6, and then with 4 it's 12. Wait, no. Yeah, so with 3 it's definitely 6. For 4 it's 4 times 3 times 2 is 24. Okay, what's going on? Okay, and at this point you skip the question. 14 minus 16. I'm just looking at the options here. And this one just looks legit because it's got 6 here. Instead of working out the combinations, I'll probably just guess B and move on because I always spend way too long on this question.
So B.
Probably. D. Okay.
So the explanation.
D is correct because suppose flavors are A, B, and C. Initially, the number of flavors should be 7 flavors. What?
Because any dish can have up to 3 different flavors.
Up to 3 flavors.
Yeah, up to. So you can have just one.
Oh my god.
As well.
Right. Okay, yeah, 7. Use new flavor, new combinations. Up to 3 would be DDA. Right. Remember when I was saying that these were easy? Yeah, I take that back.
So some of them can be really easy. Like there are some. If I just quickly go to maybe this one, for example,
these are fine.
When they just basically express the same probability the same way in different ways. So 3/18 basically is 1/6, and you just have to spot that, which is really easy. But sometimes when you have some combinatorics questions, it can be more tricky. And with practice, you'll be able to weed out those which are more tricky and those that you can do easily. So suffice to say, make sure you do draw diagrams if you're not sure. Diagrams are really helpful for decision-making questions. So yeah, that covers all the main categories of questions. Obviously, there are variations of these, and there are more difficult, more easier questions as well. So make sure you do the full range. Do these official questions as well. And hopefully decision making goes well for you. So yeah, hopefully you found this video useful, and we'll see you in quantitative reasoning next time.